So welcome back to the 88 FA21 final walkthrough. This is the 7th question, MultiMerger. So without further ado, let's start the question. So it says to write a generator merge, which takes in a list of sorted lists that each contain integers, and it yields the integers in each of the lists in sorted order. So when we get in a double nested list that has in the first list 1 through 5, and in the second list 2, 4, 6, we end up returning 1, and then 2, and then 3, and then 4, and then 5, and then 6. So we kind of check in each list which next one to yield. Okay, and then if it's just one list in the overall nested list, then we just return the flat 1, 2, 3, 4, 5, 6, 7. And then finally, for this case, we first yield 1 and then 2, and then we go to the second list for 4, come back for 5, and then the third list for 6. Okay, so let's look at the skeleton code and see what we're given. So throughout the question, I'm just going to be working with the first doc test to try to base some sort of idea of how we're going to work through this question. So the first thing they give us is indices equal to 0 in a list times length of list. Okay, so in this first example, the length of list is 2. So what we end up having is 0 and 0. And I'm going to guess that based upon the name indices, this is going to represent what index I am in each of the lists. So right now we're starting off in the 0th index in both of the lists in the list argument. Okay. And then we have a while true. So I'm going to guess this is what allows us to yield all of our values. And then we have a smallest, which is first float infinity. Okay, so that means I want a new smallest, obviously, because I do not want to yield infinity. And then the smallest index, which is -1. And then, so maybe that -1 is going to end up mattering. Okay, and then we see we have a for loop. So what is the for loop potentially going to be? Well, when I'm checking for the first value that I want to yield, or I guess any value that I want to yield, I want to check in all of the lists in that overall nested list, right? So I want to check first, what is the smallest? Well, it's 1, but I've had to also check in the second list to make sure that there wasn't like a 0 or a -1, etc., etc. And then after I'm done yielding that 1, I have to look in the list 1. There's 3, 5 left, and there's 2, 4, 6. I defined that 2 was the smallest. So maybe this for loop is going to let me look into all of my nested lists. Okay, so if that's the case, what I can potentially do is say for I in range of indices, or sorry, the length of indices, because we can only call range on an integer. So what this is going to let me do is I is going to take on the values of all of the indices, or rather all of the indexes in my indices list. So it's first going to be 0 for this one, and then 1 for the second one. Okay, so with that in mind, what do the values of 0 represent? It represents which index I'm currently on in the list that corresponds to that position. So 1 through 5 corresponds to the 0 in the first spot, and then 2, 4, 6 corresponds to the 0 in the second spot. Okay, so if that's the case, then index, or what index I'm on in the list, corresponds to indices of I. So the index I'm currently on for the first list is going to be indices of 0, which is going to be 0. Okay, next, what I want to do is, well, first of all, I want to make sure that my index is actually within the length of the list that I'm currently on, right? So what I want to say is if index is less than length of list, right? And so the reason that is because indices of I could be some value like, let's say 3, but that might not necessarily be an index in the list that it corresponds to in my input, right? So if I wanted to do my input of 3, that wouldn't work because I only have indexes 0, 1, and 2 in this 1 through 5 list. So I want to check to make sure that that doesn't end up happening. Furthermore, I want to keep a running track of what is the smallest. And that was kind of hinted because we have this smallest value. So if this value ends up being the smallest, and I can check that by saying list of I is going to give us the correct list. So for example, when we're working on this 0th index, it's going to give us this 1 through 5 list. And then I'm not done there. I also want which index I'm currently on. So in this 1 through 5 list, I want, in this case, the 0th index, which is 1. And if that's smaller than smallest or equal to, then I want to change smallest to whichever that value is. And we just got the value is right here. So let me just copy that over. And then we also want to change the corresponding smallest index because that is the index of where we want to yield from. And so in this case, that would be that 0th index. And what we would write is I, because that's the current, I guess the current position we are in the initial list that's being passed in. Okay. And then we can go over another iteration to kind of see what's happening. So we're going to check indices, so I is now going to be equal to 1, right? And so index is equal to indices of 1, which is now this 0. And we're checking if index is less than length of list of I. So list of I is list of 1, which is this 2, 4, 6. So because 0 is less than 3, we're good. And then we're checking if list of I of index is less than or equal to smallest. So list of I is going to end up being this 2, 4, 6 again. And then of index is 0, so this 2. And is 2 less than or equal to 1? No. So therefore, we're not going to execute this code, and we're going to stop because there's no more lists to iterate over. Okay, cool. So a question that might come up is, why can I only check the first index in each of the lists? And the reason is because we're assuming that they're in sorted order, ascending, which means that we always only have to check the current index we're on, right? So I don't care about this 4 or this 6 yet because 2 is less than them, and I want the minimum value. Okay. The next thing is, how can we know when we're done? I'm assuming what this if statement is going to do is kind of terminate us out. And our hint is the smallest index is equal to -1. So if I never change my smallest index, then that probably means that I have no more values to return because there was no value which was less than infinity left, which means that there is no more values. So if smallest index is equal to -1, I'm just going to return and end the program because there's no more, there's just no more elements to yield. Okay, and then we see this indices of smallest index plus equals 1. So what exactly is the point of that? Well, let's say our smallest index in this first case was our 0, right? So it was corresponding with this 1 here. And so that smallest index, we want to plus equals 1 because we've kind of used that value. We've used our 1, so we don't want to continually yield 1 forever. So we kind of move forward that list. So now we start on the first index. In other words, the next time we look for a minimum value in these two lists, now I only look at 3 and 5, or rather just this 3, and I compare it with the 2, rather than comparing the 1 with the 2 like we did in the first iteration. And so this prevents us from accidentally using an element multiple times, and I just advance to the next largest element. Okay, so finally, I actually have to yield something, and that's going to be smallest because that's going to be the smallest index, or sorry, the smallest value that I've seen in all of the lists. And so finally, that ends the question. Thank you for tuning in.